Okay, so for pre-lab experiment 4, we are going to explore Simbucket. Okay, welcome to ChemSync. Put your name in. Okay, and we have two category. First, we will explore the tutorial, and after that, we will solve the problems. Okay, so, but before that, we have to go to the tutorial. Okay. The behavior of gases. Try different setting and list as many observations as you can about how the atoms are behaving. Okay, at first I will put helium in, one particle of helium. Okay, two particle of helium. See how the atoms move. They collide, elastic collision. They collide also with the wall of the container and in between the gas particle. Okay, if I put neon, neon has slightly bigger size, so we can see the speed of neon is a bit slower compared to that of helium. And then argon, okay, even larger in size. Okay, what about the speed? The speed is even slower compared to helium and neon. Okay, if I heat up this container, okay, the speed increase, slow down when the temperature decrease. But we can still see the difference in speed between the helium, neon and argon. Okay, the larger the size, the slower the speed. Okay, the speed of the atom depends on the temperature. Okay, true. Different types of atom move at the same speed as long as they are at the same temperature. False. Different types of atom doesn't move at the same speed. It depends also on their size. Correct. Okay. Lighter atom moves slower. Heavier atom moves slower. Okay. In a sample of one type of atom, all of the atom will move at the same speed because they are at the same temperature. False. Okay, good job. As you can see in the sample to the right, some of the atoms are moving slower and some are moving faster. Okay, ada yang bergerak lebih perlahan, ada yang lebih laju, walaupun dia sama jenis. Okay, there will always be a mix of speed in any gas sample. That is why we always refer to the average speed of the atoms. Sebab kita ada purata. Okay, ada yang perlahan, ada yang lebih laju, so kita mesti ambil yang purata. Okay, pressure, force over area. Okay, the air molecules around us create pressure. In fact, the normal atmospheric pressure is around 15 psi. That means there is about 15 pounds of force being applied to every square inch of your hand and the rest of you by the air around you. Sebenarnya ada collision antara udara dengan kita punya skin. Sebenarnya ada tekanan ke atas kulit kita. Okay. So, macam mana force ni terhasil? What is creating the force inside the container? Okay. That is being measured by pressure gauge. The force is caused by the impacts of the atom with the side of the container. Okay, kita boleh ubah-ubah suhu sini. Okay, at lower temperature, we can see the pressure is low. When we increase the temperature, the pressure also increase. Okay, take another reading at different temperature. Okay, Even higher temperature has more pressure. So you can see the points, the data that we take. Okay, pressure and temperature are directly proportional. Okay, the collision of the atoms with the wall of container are highlighted by the above highlighted above. Pelanggaran antara zarah dengan dinding tu yang dia highlight tu. Okay, kalau kita tingkatkan suhu, lagi banyak pelanggaran dengan dinding bekas. So as the temperature increases, the pressure increase because the collision between particles and the walls of the container also increase. Okay, as temperature increase, pressure increases because of two reasons. There are more collision with the sides of container. Okay, also the collision is more forceful because the atom are moving faster. Collision tu juga lebih bertenaga. Okay, so apa yang atas kali ni? Increase in temperature, I think. Okay, will causes increase in speed. Okay, that means the increase in collision force. Tak mahu sini. And collision frequency. Pelanggaran dia lebih bertenaga dan lebih kerap. So, which together cause an increase in pressure. Okay, ini let's consider the number of atoms. Use the buttons to adjust the number of atoms. Then take a reading. Okay, kalau saya kurangkan bilangan atom, take reading, pressure dia rendah, tambah 2, take reading, slightly higher pressure, tambah banyak, even higher pressure, take a reading. You can see that the pressure and number of atoms are directly proportional. When we have more number of atoms, the pressure that is created is higher. Okay, sama juga. Banyak bilangan atom. Tengok sini pelanggaran lebih banyak. Pressure tinggi. Okay, it also has the relation to the collision between particles and the wall of the container. More collision. So when we have more collision, higher the pressure. Okay, an increase in the number of atoms, increase in the number of collision, which causes increase in pressure. Okay, take reading. This is between the volume. I can decrease the volume. When the volume decrease, the pressure is higher. Higher. Kita tengok sini. Okay, I will decrease the volume even more. So pressure increase. Okay, kurangkan lagi. Lagi tinggi pressure dia. Okay, pressure tinggi untuk saiz kecil. Bila besar, pressure decrease. Okay, volume besar, volume kecil, tekanan tinggi. Volume besar, tekanan rendah. Okay, it has the relation to the collision. Okay, tengok sini bacaan dia. Saya kurangkan, tinggi. Bila kurangkan, tengok collision between the particles and the sides of the container tu lebih banyak. Yang dia highlight tu ni, relax sikit. Yang highlighted area tu kurang sikit. Okay, a decrease in volume causes increase in number of collision, which causes increase in pressure. Okay, so we can return to the home page and go to the problems.